Alright, let's now take a look at a workflow which allows Product Design Suite users to leverage existing AutoCAD layout data. So we're going to start here in AutoCAD Mechanical. This is a layout of the ARM system for the VMech ATV. And what we're going to do now is we're going to insert the gripper claw onto the end of the arm here. So we're going to pull in this as an AutoCAD block. These are all existing AutoCAD elements that this company has used for a while. We're going to use some of the snap tools here to locate it as a block relative to the rest of the assembly, and let's go ahead and zoom out. Now, a lot of these components, most of what we're looking at here in the layout is saved as blocks. This is done for a number of reasons, but the company's been in business doing these layouts for a long time. They typically will have a lot of this two-dimensional layout data around. So this workflow now is going to allow us to leverage that existing AutoCAD two-dimensional layout data as the basis for a three-dimensional fully articulated assembly. So we're going to use the DWG DWF import wizard here. We've selected the layout that we were working on a moment ago, and now we're going to select the layers themselves that we wish to pull into this new sketch, this new part that we're creating here in Inventor. So very important there, you'll see that we have AutoCAD blocks to Inventor blocks turned on. That is a very important step here because that's going to basically set the stage for creating this very, very full-featured, articulated two-dimensional layout, which you'll see in a moment, which we were going to use to turn into a three-dimensional layout. So here is in Inventor, we have a single part now with all of the blocks. These were AutoCAD blocks in AutoCAD. They are now sketch blocks in Inventor. This again, it's a single part right now, but this is a single part which represents an entire assembly. Now we'll save it at this point. The workflow that I typically like to use is have the layout part and the assembly that's going to follow both have the same file name, just with different extensions. One obviously is an assembly, one is a part. So we'll go into the Manage tool and we're going to utilize Make Components, and we'll select all of the sketch blocks, which are the components which make up our layout. Now these are about to become individual IPT files as part of a layout IAM assembly file. So go ahead and save our assembly. This is the location and hierarchy of the individual parts which we've selected, which are going to be generated from the sketch blocks. These parts are going to automatically be constrained to the layout plane, and we've also selected the option to automatically create assembly constraints from the constraint relationships which exist at the sketch level. Now, here's our layout. We're in an assembly. Some of these components are going to be grounded initially because everything is going to be constrained to them. These are the components which mount to the back of the ATV trailer, the VMech trailer. And now we're going to take the upper arm assembly and we're just going to move it off of the base. And we're going to go ahead and add a mate constraint between the axes of these two elements. Now keep in mind the base is grounded, and now we can rotate our upper arm assembly based on that assembly constraint that we just added. Also keep in mind everything again is mated flush to the layout plane. Now, long story short, we start developing these 2D components into full three-dimensional parts. The beauty of this methodology is that all of the assembly constraints, which are either added automatically once the layout is imported, or the ones that we add manually, as you just saw me do a moment ago, all of those are maintained even as we convert these two-dimensional layout parts into three-dimensional parts. The process for that, of which I'm going to show you right now. So we're going to utilize another AutoCAD DWG file, which is used. This is a detailed drawing of this component, which is the lower arm assembly, which is in our layout. Now we're going to utilize one of the sketch views, so we don't want to select all. We're just going to window select this upper view right here, and we're going to import that, imported units. We're going to constrain endpoints automatically, and we're going to import that into our existing IPT file, into our existing part. Now let's locate a point. This is going to be a reference point which exists in both of these sketch views. Now this is going to allow us to essentially move this into position very quickly and easily. So we'll use the sketch move tool. We'll window select the elements that we want. We will reference that point that we just added, which is actually the center point of this arc right down here, and you'll see right there, there's the point. I'll just snap to that right now, and that moves these sketch elements that we just imported from AutoCAD into location. Now, very important here because as you can see, all of the dimensions from AutoCAD are preserved, and we're going to actually use those sketch dimensions as the basis for our parametric dimensions, which are going to drive this model. So that value of 5 millimeters for the thickness of this plate, we'll select the AutoCAD dimension which we just imported. We also have the option of selecting between work planes for that distance, so let's go ahead and select that. And now we're going to create a new mirrored copy of this component, mirrored about that plane right there. We're going to have it in there as a new solid, so we're going to utilize multi-body technology here to help us in the creation of what is ultimately going to be a weldment. Now let's turn this original sketch back on again, and we're going to use the extrude tool, and we'll pick this main beam element. We're going to create it as a new solid. We'll drag our distance. In this case, we want it to be symmetric about the center plane, and we want the distance to be, again, from the dimension that we imported from the original DWG file. So let's go ahead and turn off the sketch, and let's go ahead and add fillet. We're going to round these corners to about 4 millimeters. Let's select each one of the 4 corners of our beam like so. Let's change this to 4 millimeters. Go ahead and add that, and now we can go ahead and shell. This is going to be a 2 millimeter thick beam element, so let's select those faces as open faces. We'll select our wall thickness of 2 millimeters, and that is that. Let's go ahead and turn the sketch off, visibility. And now let's turn on the visibility of the other elements in this weldment, because we want it to look a little bit more full featured when we bring it back into the top level assembly. Let's turn off the visibility of that sketch. And there we have our lower support arm assembly. Now again, the beauty of doing this layout mode is that all of the constraints are automatically maintained as we develop the parts from a 2D layout into a full 3D assembly. This is one of the biggest advantages of using these digital prototyping tools